Assalamu alaikum. My name is Salim Salim, a mechanical engineering student in BMU University. I would like to present you my project, which is about the history of vibration analyzer. I hope that enhance your knowledge and give you a brief idea of this useful instrument. This is my outline, the introduction, what is the vibration, historical background, causes and effects of vibration, technical use of vibration analyzer, conclusion, and my references. Today, vibration analyzers are important instrument in machinery's operation. It protects machineries and increase its operation life and minimize equipment downtime by detecting potential failure and promote equipment reliability. Rotating equipment normally creates vibration, but unwanted vibration should be detected to protect machines' future malfunction. Moreover, vibration analysis gives cost-saving approach in equipment's predictive maintenance, thus giving advantage on equipment availability and safety. Vibration is the physical movement or oscillation of mechanical part about reference position. We care about vibration because vibration wasted energy, and it is the major cause of premotor equipment failure, and it, it cause of effect noise which contribute to crew and passenger discomfort. The first vibration analyzer was the human brain coupled with the sense of touching and hearing by using screwdriver on the nearest part to the bearing. The first vibration meters were introduced during the 1950s and measured the overall or broadband vibration reading. These first vibration meters were along meters. Little later, Temple along filter were added to meters in order to make it possible to discriminate between frequency components, gives breadth to vibration spectrum. In 1970s, brought forth the personal computer and the advent of digital signal processing that led to the FFT, which means Fast Fourier Transform Analyzer, and it make quick work of calculation frequency spectrum from a recording vibration signal. In the 1980s saw the explosion of the microprocessor of signal silicon chip and the battery powered truly portable digital signal analyzer quickly followed this. It is device coupled with the computer program that store the data and take care of logistic of vibration data collection that have revolutionized the application of vibration analysis to machinery diagnostic. To today, Emerson Electric Company has developed a more efficient and reliable vibration analyzer for vibration analysis to machinery diagnostic. In June 17, 2013, Emerson released the faster and more powerful CSI 240 machinery health analyzer. While the while the CSI 2140 is the leading analyzer on the market today, and most of the company they are use this machine, like Saudi Aramco. Couple imbalance and angular misalignment and parallel misalignment and bent shaft are some of causes of vibration, and all of these causes will affect to the bearing or to the shaft of equipment, and it will decrease the operational life of the equipment which leads to spend money for replacing the bearing or the whole equipment. And here we will see how we can use this instrument.
Use the yellow Measure Hard key to select the previous setup for measurement. On a variable frequency drive, it's recommended to re-enter the actual running speed value, as the speed will vary with the load. The numbers at the top of the drivetrain image indicate the measurement locations. Choose the first location and mount the sensor. Typically, rotating equipment will vibrate in 3 different directions or axes. The triaxial sensor can collect vibration signals from these 3 axes simultaneously. Sensor orientation screens help the tester understand from which axes vibration signals are coming. By testing certain points along the entire drivetrain rather than a single component, the tester can account for transient vibration from other sources and give you a more comprehensive diagnosis. The sensor needs to be located as close as possible to the bearing or on a solid structural member leading to the bearing. You can select any of these measurement locations to start. From these marked locations, you can place the sensor either at the top, bottom, side, or end. Take vibration measurements when the machine is running at a steady state and at normal operating temperature. All of the measurements must be completed within 30 minutes to minimize the risk of varying load conditions affecting the diagnosis. If the drive motor has more than 40 horsepower and is longer than 40 inches, it's recommended to take 2 measurements from each component in the drivetrain. Otherwise, 1 measurement from each component will suffice. Push Enter to select location number 1. For this demonstration, we first put the sensor on the motor's free end at the top, where the cable is perpendicular to the shaft. Whenever possible, place the sensor parallel or perpendicular to the shaft. Attach the sensor to a clean, flat, bare metal surface. Avoid thin surfaces like shrouds or uneven surfaces like cooling fins. Thick layers of paint, grease, oil, or other matter will reduce both the holding force of the magnet and the high frequency response of the sensor. Take care when attaching a magnetically mounted sensor. Hold the sensor firmly and roll it carefully onto the test surface to prevent any jarring and potential damage to the sensor. Press F3 or Enter, or use the dial to select the orientation. In this case, we located the sensor at the top of the motor rather than the bottom, side, or end, and perpendicular to the drive shaft. Having completed the sensor orientation, we're ready to collect data. Push F3 to begin. Once that's done, push F4 to continue on to the next location. If the orientation of the sensor remains the same in terms of location and cable direction, hit Copy Last to use the last orientation information. It's important to use the same orientation each time you take measurements at any given location to maintain consistent diagnostic records. The tester also has onboard context-sensitive help to provide practical information on a variety of subjects, from sensor placement and orientation to interpreting the diagnostic output.
In our present civilization, technology such as vibration analyzer had contributed a lot for efficient and more safety methods to test these rotating equipment machineries. We can find vibration analyzer either portable or fixed probe. Vibration analysis can be efficiently monitored and recorded on a huge motor vehicle and high-speed pumps and turbine and any rotating equipment. And these are my references. Thank you.